On air. 16 questions.
This one should be pretty easy.
Yeah, I certainly hope it goes quick.
Yeah.
Okay, question 3. In a pie chart, why are the slices, sectors different sizes?
Got the third one down.
Yeah.
Yeah,
That's a nice question. I like that one.
please keep them coming.
Yeah.
Okay, how are bar charts and Pareto charts related?
Bottom one. The only difference between a bar chart and Pareto chart, bars and Pareto chart are ordered largest to smallest.
Agreed. I'll take the next one. It says we conclude that P is normally distributed NP greater than or equal to 10 and N1 minus P is greater than or equal to 10. Is P the true proportion or the sample proportion?
P would be the true proportion
Yep.
because P hat would be the sample, right?
Mm-hmm.
Yeah.
Okay.
What is N?
Sample size.
Yep.
Okay, if P equals 1/4, what is the smallest n that satisfies the requirement?
4? I don't know.
It's got to be
So
10.
it's n. Okay, P is 1/4. So it's 75.75 times n that's greater than 10.
So essentially, it's got to be less than or equal to 10. So if you take 0.25 and divide it by 10, you get 40.
Wait, say that again.
So we've got P is equal to a quarter, 0.25. In order for
Right.
to satisfy the requirement, P has got to be equal to, or it's got to be greater than or equal to 10. So you take 0.25 divided by 10, and you get 40.
Makes sense.
So it's 40?
That's what I've got. That's what I understood from the question anyway.
No, it makes sense as soon as you explain it to me.
Wait. So wait, you divided 0.25 by 10?
You times
10 divided by
10 by
0.25?
0.25.
10 times 0.25. Wait.
Or wouldn't it be 10 divided by 0.25?
Yeah, okay.
You're right.
Yeah.
You're right. You're right.
Okay, now I got it. What's going on?
Mm-hmm.
Yeah.
What is the standard deviation of P hat? I don't remember how to calculate the standard deviation of it.
Wait. Aren't we on 8, which is what's the mean of P?
Right, the mean of P.
Oh, I put it 40 in the wrong one. Okay.
Yes, we are.
So the mean of P hat is just P, isn't it? So it'd be 0.4.
Yeah, P is 0.4, mean of 0.4 rights. That makes sense.
I'm sorry, what did you say for 8?
0.4.
So
Right.
based on the reading, it says that so P hat, the mean of P hat is P.
P.
Okay, so
So-
the mean of P hat would just be the... Okay, gotcha.
Yeah. And what is the standard deviation of P hat?
It's P times 1 minus P divided by n all square rooted.
All of it square rooted or just the square root of n?
All of it. So you do P times 1 minus P divided by n, and all of that is square rooted.
I've got 0.100.
The square root of p. Oops.
What did you get for your answer? I got
Mhm.
point.
0.100.
0.1.
I need to grab my real calculator.
I got 0.1. So it's the square root of p, which is 0.4, times 1 minus p, which is 0.4, divided by n, which is 24, right? And all of that square root.
Okay, what did you get?
I got 0.1 for the answer.
0.1. Okay, that's what I got as well.
Yeah. Oh, okay, cool. Did you get something different there, Aaron?
No, I got 0.1.
Oh, 0.1. I thought I heard 0.01 for some reason. Okay. Perfect. Did you get that, Skylar?
Yeah, I did. I got that same thing. So Brittany's batting average is 0.3. We want to determine the probability she will get more than 35 hits in the next 100 at bats.
What is p? That's 0.30, correct?
Yeah.
Well, no, p hat is not 0.30. So we take
Oh, but P is, yeah.
Sorry.
well,
P
p hat is so it's 35 over 100, right?
Mm-hmm.
Yeah, 35 over 100.
So it's 0.35.
Wait, just a sec. P is x. P hat is x divided by n. X is 35 divided by 100. Okay.
Yeah.
35.
Yeah, 0.35. All right. What is the standard deviation of p hat? So it's that same formula, isn't it?
0.046.
Yeah, that's what I got. 0.046.
And for this one, is this, you did P minus 1 minus P divided by the sample size, and then all of that is squared?
Mm-hmm.
Oh, okay, because I tried to do that, and I got an error.
Okay.
The
you
square
have-
root. You said not squared, right?
Okay, so you have 0.3 times 1 minus 0.3.
Oh, times 1 minus 0.3. That's what I'm doing wrong.
Then you divide all that by 100, right?
Yeah. So now we're good.
And then you do the square root of that. I get
0.058.
0.045.
0.0458. That's what I meant to say.
Right.
Four, 5, 0.046, correct?
Yep.
Rounded. Okay,
Yeah.
sorry, I'm a little slow tonight.
And the
That's
Z
all right.
score for the next one, I got 0.935.
Did you use the applet to find that?
Yeah, I just plugged in 0.35 up at the top.
Okay, so z-score is value minus mean divided by standard deviation.
I got 1.091 is the z-score.
You got 1.09,
Yeah.
and you put in, what number did you put in at the top?
So I've got it set up as a calculator in Excel. So it calculates the p-value, power of p-value, or p-hat, and then total sample size. And it's
What's the mean on that one? My calculation stuff's all over the place. That's 0.3, right?
0.3. Yeah.
Yeah, it's P.
So it's p-hat minus the p-value divided by the square root of the p-value multiplied by 1 minus the p-value divided by total sample size. And I got 1.091. And then you plug that into the app, the probability app.
$1.590, right? You guys got 1.590 correct for your z-score.
1.09.
1.09.
Yeah.
Okay, so you have your 35 minus 0.03, correct?
Yeah.
And then you divide that by the standard deviation, which is your 0.0504546. I need to round that one.
Did you get 0.862 for the probability?
I got 0.137, or yeah, 0.137.
Okay, I'm still getting something different for the z-score. I'm getting 1.596.
Let's see. Let me just check my formula. Okay, so when we're looking for the z-score, we don't use the standard deviation. It's p-hat minus p divided by the square root of p multiplied by 1 minus p over the sample size. So in this case, it would be is it 0.35 minus 0.3 divided by the square root of 0.3 multiplied by 1 minus 0.35 versus 0.3 all over 100.
So your value you have is 0.35 or 35?
0.35. We're looking at probability. So it's essentially 35%.
Okay, that's the reason why, because I have it as a full decimal. I mean, a full 35. Whoa, that really changed the buzz.
35 would be the observation, but the actual p-hat statistic is that 35 divided by 100, which gives you the 0.2.
Okay, what was it again?
1.091 for the z-score.
And then what was 13 now for that?
So if I did it right, I'm shading everything to the right, which is everything greater than 1.091, which I think is what we're looking for. If that's the case, then it's 0.1376.
0.1376, correct?
Or 0.138 if it's rounded to the decimal.
Okay, I was shading
0.138.
everything. I was shading everything from the middle to the left. That's how I got my number.
But you're supposed to do it
Yeah, you
least,
do.
so it's to the right. Okay, so for 14, if the true proportion of people who support a political candidate is P equals 0.52, and if N equals 2,000 people who are surveyed, we want to determine the probability that the results of the survey will suggest the candidate is losing the election. Well, you have N times 0.25. What do you need to? Oh, sorry. What is the standard deviation?
So that's 0.52.
Is it 0.011?
That's what I've got.
0.00, 0.011.
Mhm.
Yeah.
That's what I have as well.
11, okay.
And the z-score.
So for this z-score, do you guys use 0.5 as p hat?
Use 0.5, not
Yeah. I mean, this is
because of the part in parentheses. Is that what you're talking about?
yeah.
I didn't use
Getting
0.5.
less than 50%.
Because that's what was a bit confusing on the homework was some of the questions that didn't give you p hat, and there's not enough data to figure it out. So it's kind of a word problem. You have to kind of decipher it in the way that the problem's worded.
Yeah. Determine the probability that the results of the survey will suggest the candidate is losing the election, getting less than 50% of the votes. Yeah, that makes a lot of sense why you would say, but then we would, our number 14 would be wrong because we would get the standard deviation of P rather than P hat.
Well, not necessarily, because you use P to determine your standard deviation of PV.
Oh, we do? Oh.
Huh?
Thought we just used. Okay, yeah, never mind. That's what we've done the other problems.
Mm-hmm.
Okay, wait. P hat is 50. So we're
0.5, right?
5, okay. We still get 0.11 for the first one, okay.
Right.
I think I'm doing my z-score formula wrong. In fact, I know I am because my number doesn't make sense.
Excuse me.
Okay. I get a negative 1.789 for the z-score. Is that what you guys get?
Yep, that's what I got.
What was it again? Negative 1.79?
789.
So Nathaniel,
Oh, 7, 8.
are you using Excel to solve that as well, or do you have the formula there?
I used Excel to solve it, but I had to look at the formula to get it.
Oh.
And the z-score formula is p hat, which in this case is 50%, minus p, which is 0.52, all divided by our standard deviation, which we calculated before as the 0.11, whatever it is.
So it's P hat minus P
All
divided by the.
divided by the standard deviation, yes.
Okay, so
So
Or by
I
the square root of the
used,
deviation. Oops. I may have messed up.
right. So, yeah, so I did
No, I
the
didn't,
square
because
root
I-
of,
Yeah, it was right.
I'm
Go
still
ahead.
getting a little, so 1.79, I got negative 1.79 because I didn't divide by, I think it's because I didn't divide by the standard deviation. I just put the rest of the numbers into the formula.
Okay, what number are you subtracting from? Is it 0.5 that you're subtracting from, or 0.52?
So I did so I did 0.5 minus 0.52 divided by the square root of 0.52 times parentheses 1 minus 0.52 divided by 2,000 close parentheses.
Did you do the square root of that second part? Of
Yeah.
what you're dividing by?
Right, I did the whole,
So you-
the whole denominator square rooted.
And you're still coming out with negative
1.79.
1.79. Now, are you rounding to the? Is your formula rounding to the decimal points, or is that as far out as your decimal
No.
points go?
So
Yeah, no, it's going out to the
I got
5
negative
decimal points.
7.9 as well.
7.9. Oh, I think I did it again.
You know what I think it is, Nathaniel, is that, didn't you say you were dividing by the standard deviation? I would just plug in the numbers straight into that denominator of the formula.
Oh wait, bother. Okay. Okay, so you take 0.5 minus 0.52, then you
Right.
divide that by the standard deviation, which is 0.011, correct?
No, so I just plugged it into that formula that's there in the textbook, where it's the square root of p times 1 minus p divided by n.
Okay. Okay. Okay, I messed up, so I'll have to look at it later. What did you guys get? Again, negative 0.19, 0.9,
179.
179.
Negative 1.79, excuse me.
Okay, negative 1.179.
Just negative 1.79.
Okay.
So is there another decimal place on that then?
I guess, would it be 0, Aaron? Do you see that? Or would it be 1?
It's negative 1.790.
Okay. Yeah.
Yeah, there you go.
Yep.
And then it's everything to the left of that, right? Of that z-square.
For the
Yeah.
probability.
Because you're looking at 50% or lower.
Yeah. So 0.036, 037. That seems bad.
1037. That's what I'm.
367. 337, yeah.
So, but it's asking. The true proportion is 0.52, so it's 52%. And it's the probability that, given that 52% of the people are showing that they're going to vote one way, what's the probability that the candidate will lose the election? What's the probability that the survey will suggest the candidate is still losing?
Oh, okay, gotcha.
So it's a relatively small percent that will show he's losing, even though he's got the popular vote.
Right.
Thank you, President Trump.
Well, there we are. So that's done.
Who wants to submit this week?
I can submit. %.
Oh, heck yeah.
It's, all right.
All right,
Perfect.
awesome.
Same here. Same time tomorrow night, or what?
I'm good with that.
That should work for me, yeah.
Yeah. I think I can make that work too.
Sounds good. See y'all then.
Cool.
Yep.
All
See
right,
ya.
take care, guys. Bye.